Alright, on this video I'm going to solve some problems from section 4.2. So this is going to be section 4.2, solutions to homework problems. Now, it's not my intent to solve every problem in the homework. In fact, I'm probably not going to solve a majority of the problems in the homework, but I'm going to solve a representative sample of problems in the homework to try to help you. If you've encountered trouble with any of these questions, then we can, take a look at this video and say, okay, this is what Kevin did on that one, so now I can move on and try that on problems X, Y, and Z. So, section 4.2, remember, was maximum and minimum values. And here in section 4.2, we had critical numbers. We didn't yet know in section 4.2 what to do with critical numbers in terms of finding local mins and local maxes. However, we did know how to find an absolute min and an absolute max on a closed interval. So I'm going to work out some of the problems here in the book. So I'm going to start with question number 7. All right, I'll start with question number 7. Now, question number 7 says, sketch the graph of a function f that is continuous on 1 to 5 and has the given properties. So we're continuous on the closed interval from 1 to 5, and then what are the properties that they've asked us? We need an absolute max at x equals 2. We need an absolute max, oh, I'm so sorry. That's an absolute minimum at x equals 2. We need an absolute max at x equals 3. And we need a local minimum at x equals 4. All right, so we need a graph that contains all of these. Now remember, we're only allowed to play between 1 and 5, right? So 1, 2, 3, 4, 5. This is where we're allowed to play. Now we need a continuous graph. Remember, that's a graph that has no holes, no jumps, no vertical asymptotes, or our definitive definition of continuity is I can draw the graph without lifting my pencil. That's a joke. That's not our definitive definition of continuity. Our definitive definition of continuity is the limit as x approaches a of f of x equals f of x. So what do I need? I need an absolute min at x equals 2. Now your graph is not going to look like my graph, right? We're not going to have similar graphs here. But we need an absolute min at x equals 2. So this is 2, right? We got 1, 2, 3, 4, 5. So I'll put my minimum down here. This is going to be my absolute minimum. Now that has to be the smallest point on my curve between 1 and 5, inclusive of the endpoints. That's the definition of an absolute minimum. Now I need an absolute max at x equals 3, so I'll put that point up here. Now, it does not have to be the case that your minimum is negative. It doesn't even have to be the case that your maximum is positive. Your maximum could be right here. It's bigger than this. It's still negative, but we don't care. It's bigger than this. And then we need a local minimum at x equals 4. Now, my local minimum can't be smaller than my absolute minimum, so I'll put a dot right here, right? Now, it said we need a continuous graph, right? A continuous graph from 1 to 5. So 1 and 5 are closed. So where am I going to start? Well, I'll start here, and I'll come down to my absolute min, and then I'll come back up to my absolute max, and then I'll come down to my local min, and then I'll just come over here, and we'll stop at 5. So this is an example of a graph that has an absolute max here. It's the biggest y value. This is my absolute min. It's my smallest y value. And over here I have a local minimum. Remember, local minimums, you have to be able to approach from both sides, right? Both sides. This is not a local max. because I cannot put an open interval around the point 1. My domain starts at 1, therefore I can't put an open interval around 1. There is no left-hand side to that interval, therefore that is not a local minimum. All right, so that's number 7. Let's move on here, and we'll just jump down to maybe number 23. So what does number 23 say? 23 says find the critical numbers, right? Find the critical numbers. We'll do a couple of these. Now remember, what's a critical number? A critical number is f prime of x equals 0, or f prime of x fails to exist, right? Those are our definitions of critical numbers. So the first step when we're asked to find a critical number is to write down the function and take its derivative. So we have f of x equals 4, right, plus 1/3 x minus 1/2 x squared. Right? That's my function. So I'll need the derivative of that. F prime of x in this case is going to be 1/3 minus, we bring down the 2 and we get 2 divided by 2. So that's going to be 1. So 1/3 minus x. Well, that's a fabulous derivative because first of all it's linear. So it only has 1 0. And it never fails to exist because it's a polynomial. So how do we find critical numbers? My suggestion is you make a chart, right? You say f prime of x equals 0. You do your work here. You have 1/3 minus x equals 0. And then what does that get me? That gets me to bring the x over here, and I get 1/3 equals x. Then we should also always check to see where f prime fails to exist. If we leave this off, our instructor is going to be tempted to believe that we didn't know we were supposed to do that step. By putting it here and saying NA, right, NA, f prime of x is a poly, then we really eliminate the opportunity for the instructor to say, well, you failed to check to see where it fails to exist. Now let's do another problem, all right? Let's do another problem. Let's take, now it'd be really nice if I remembered which one of these I did during the lesson. So if I've done one of these previously to this, well then I apologize for that. So let's take 35. We have f of theta. Why am I taking 35? Well, because theta is, or 35 is a trig problem. So we have 2 cosine theta plus sine squared theta. Right? Now remember what our goal is here. Our goal is to find the critical numbers, right? That's what we're looking for. When does the derivative equal 0? When does the derivative fail to exist? So from here I'm going to take the derivative, right? F prime of theta is equal to, the derivative of 2 cosine theta is minus 2 sine theta. The derivative of sine squared, of course, is 2 sine theta, right? Power rule, down comes the 2, times the derivative of what's inside, the chain rule, times cosine of theta. Now, if we factor this out, right, we're going to have a 2. We can factor out a sine theta. And if I factor out a 2 sine theta, that's going to leave me negative 1 plus cosine of theta. Now, I'm going to add over here a condition. I'm going to say we're just going to look for critical values between 0 and 2 pi. So what do we know? Well, we have to check to see where f prime of theta equals 0, right? So that would be where? Well, that would be where sine theta equals 0, or where negative 1 plus cosine of theta equals 0. Now, what about f prime of theta fails to exist? Well, that's NA because sine and cosine are defined everywhere. So what do we get here? Well, to solve this, right, so the quickest way to solve when does sine equal 0 is just to draw yourself a quick graph of sine. Sine is 0 and 0 and 0 pi. I've got an open interval at 2 pi because we don't want to double count 0 and 2 pi. So what do we get here? We get theta equals 0 or, right, theta equals pi. Now, over here, this equation becomes cosine of theta equals 1, doesn't it? Now, how are we going to find a solution to that? Well, again, the easiest way to do something like cosine theta equals 1 is just to draw a graph. Cosine of theta equals 1 here and here, but of course, we're open at 2 pi, so we get, again, theta equals 0. So our critical numbers, right, our critical numbers are theta equals 0 and theta equals pi. Right? So that's how we go about finding critical numbers. We take the derivative, we set it equal to 0, and then we solve. Right? We solve. All right, I'll do a couple of more examples here from the homework. I'm going to clean this a little bit. So what else are we asked to do the homework? Well, we're also asked to find absolute mins and absolute maxes. Now, how was it that we were asked to find this? Well, remember, when we're finding an absolute min and an absolute max, there's another added step. First, we're going to find the critical numbers like we've done before, and we're going to plug those into the function to see which is the biggest y, that's going to be my absolute max, which is the smallest y, that's going to be my absolute min. But that may or may not be the case because we have the added step now, right? The added step of having to check the endpoints. We don't want to forget to check the endpoints. So I'm going to take a swing here at question 47. Question 47 says f of t equals t times the square root of 4 minus t squared. And the closed interval we're asked to work on is 1 to 2. All right, 1 to 2. Now, what do they want me to do? Well, they want me to find the critical numbers. I have to start there. We can already evaluate f of -1, right? We can put -1 here, we get -1, we can put -1 here, we get the square root. Well, this would be -1 squared is 1, 4 minus 1 is 3, -1 times root 3, we get minus root 3. And we can plug in a 2 as well. We're going to get 0. But before we do that, it's simpler if we first find the critical numbers and then evaluate everybody at the same time. So I'm going to find the derivative of this. Right now, the derivative of this is going to require the product rule. That's no big deal. We can do the product rule. The derivative of t is 1, so I have the square root of 4 minus t squared, right? Plus t. Now, remember, 4 minus t squared is 4 minus t squared to the 1/2. So when I take the derivative of that, I get 1/2. I get 4 minus t to the, t squared to the minus 1/2. And then I have to take the derivative of what's inside. The derivative of 4 is 0. The derivative of negative t squared is minus 2t. Now, what are we going to do? Well, we're going to have to factor this. So this, right, this is 4 minus t squared to the 1/2, right? This 2 takes care of this half. And what do we get? Well, here we get minus t squared, yes, minus t squared, t times t. And then we get 4 minus t squared to the minus 1/2. Now, this is one of those factoring situations where we got to remember to take out the smallest power. The smallest power is negative 1/2, not positive 1/2. So what happens when we pull that out? Well, if you've watched previous videos from me, what I like to do is when I factor out a negative 1/2, I like to write down what I'm doing. I find that I get the problem correct a lot more often if I express my factoring as a subtraction of exponents. That's what factoring is. So what do we have here? We're going to factor out a 4 minus t squared to the negative 1/2. And then what do we end up with? Well, when we factor out 4 minus t squared to the negative 1/2, that is subtracting a minus 1/2. 1/2 minus minus 1/2 is 1/2 plus 1/2. So this is going to be 4 minus t squared to the first. So we don't need to put an exponent on that. Minus, there's going to be a t squared here, so we're going to put that there. And over here, what is our new exponent going to be on our 4 minus t squared? Well, we have minus 1/2 minus minus 1/2. Of course, those turn this into a plus. And we get 0. So the only factor that we have that's going to end up down here is our minus t squared. So this is what we get as our derivative. Now, if we simplify this, right, this is 4 minus 2t squared divided by, because that has a negative exponent, that's going to be the square root of 4 minus t squared. That's what that's going to be. Now, what are we now tasked with doing? Well, remember, we're still looking for the critical values. So we are going to find where does f prime of t equal 0, right? That's going to be our job. And then when does f prime of t fail to exist, right? Those are our tasks when we look for critical numbers. A fraction equals 0, of course, when the numerator is equal to 0. So this simplifies to 4 minus 2t squared equals 0. That gets us 4 equals 2t squared, or 2 equals t squared. And then if we solve that, we get t equals plus or minus the square root of 2. Now, at this point, we have to make sure that we go back and pay attention to the boundaries that we were asked to utilize. We were asked to do this analysis between negative 1 and 2, inclusive of the endpoints. Well, minus the square root of 2 is smaller than negative 1, so we really only end up with one critical value here, and that is t equals positive square root of 2, right? And that is because minus the square root of 2 is not in the interval from negative 1 to 2. So we can eliminate that. When does this fail to exist? Well, it's a fraction. It fails to exist when the denominator equals 0. When does the square root of something equal 0? Well, the square root of x equals 0 when x is 0. So in other words, when this is 0, we're going to get a 0 in the denominator. We can't have zeros in the denominator. So here we're solving 4 minus t squared equals 0. We can do this one of two ways. We can factor this. This is 2 minus t times 2 plus t. Right? It's the difference of 2 squares. That gets us t equals 2. Over here we get t equals negative 2. Right? Now, again, negative 2, not in our interval. So we eliminate that. Now that we've found our critical numbers, right? Our critical numbers are t equals 2 and t equals the root of 2. 2 is still in our interval. The interval's closed at 2. So now that we've found our critical numbers, we can come over here and we can make a table of values. Now we have f of negative 1. That's one of my endpoints. We have f of 2. That's another endpoint. We have f of the square root of 2. That's one of my critical numbers. And then our other critical number is 2, but we've already got that one here, so we do not need to reevaluate that. So what are we going to do? We're going to evaluate each one of these. Now, be sure that always f, not f prime. Right? We're not trying to find out the value at f prime. We're trying to find out the value of f. When is f the biggest? You don't want to be one of those kids that puts f prime over here and then comes back to the teacher and keeps saying, you know, whenever I plug it in, it fails to exist or it equals 0. And of course it does. You're plugging it into the derivative. That's not your task. Plug it into the function. So when I plug 1 in here, what do I get? Well, I get 1, I get the square root, I get 4 minus 1 squared, right? So, sorry, we're plugging in negative 1 out. And so when we plug in negative 1, what do we get? We get a negative here. This is negative 1 squared, that's 1. 4 minus 1 is 3, so we get minus square root of 3. Now, I don't know if that's an absolute max or an absolute min because I don't know what these values are going to be. So I plug in 2, so that's going to be 2. I get the square root here. I get 4 minus, right? 4 minus. And then we're plugging in 2, so that's going to be 2 squared. Now, 4 minus 2 squared is 0. 0 times 2 is 0, so this is equal to 0. Now we plug in f of the square root of 2. We get the square root of 2, right? Square root of 2 times the square root of 4 minus root 2 squared. Okay? Well, root 2 squared is 2. 4 minus 2 is 2. And so what are we left with here? We're left with the square root of 2 times the square root of 2, which equals the square root of 4, which equals 2. All right, so these are our candidates. These are our candidates. Right? Choose from here. And if you set these problems up in a manner such as this, and keep them organized like this, two things are going to happen. First of all, your teacher's going to be thrilled because they're going to get to follow your work. And second, you're going to not get lost halfway through the problem and lose track of where you were and what you were doing while you were doing it. So what are we supposed to find? Our absolute max, right? Well, our absolute max is 2. Our absolute min. Remember, we know by the closed interval method, right? By the closed interval method, we're going to find an absolute min and an absolute max. If we have a continuous function on a closed interval, it guarantees we're going to find an absolute min and an absolute max. So our absolute minimum here, right? Our absolute minimum is minus the square root. Right? Don't write these as points. Don't write those as coordinate pairs. The max is the y value. The definition of the max is what is the biggest value of the function. That is the y value. So you want to make sure you write that as the y value. You can't just write it as, in this case, square root 2. Now you're indicating to me you don't know what I'm asking you to do. So you're just going to write them both down. And I'm pretty sure most of your social studies teachers don't expect you to write true/false for all the true-false questions. So don't expect that of your math teachers either. All right? Hope this helps you with the homework in section 4.